Hello everyone. Today we are talking about my project, and this is the project's core circuit. This called thief alarm system or laser cut system, as I said before, the last video. We are going to talk about this, not in this video, but at next videos. I'm going to solve this circuit over Pertinax, but not today. I'm just showing what this circuit does, or what's the connections in circuit. Um, this sorry, this is a Tinkercad. As you know, you can do circuit design in this application. Not application. This is a website, but you can download an application in your personal computer. But never mind. This isn't gonna big mess. So what we are doing in this circuit, uh, as you can see, I use LDR, which can interact with light, 1k ohm resistance and 10k ohm resistance, LED, in other words, a light emitter diode, a buzzer, and NPN transistor. Um, the circuit looks like this, and here's the connections. The positive voltage comes here and connects with 10k ohms leg and transistors C leg or collector leg. Um, sorry, the resistance leg, the LDR's leg, and uh, transistor space leg are connected, as you can see, and the other leg of LDRs connected with buzzer, and the other leg connected with 1k ohms leg and NPN transistors emitter base. No, sorry, not emitter base, emitter leg, and 1k ohms other leg connected with LED's anode, and the cathodes are buzzers, and LEDs are connected with each other and connected with negative line at circuit board, or breadboard, whatever you say. And you can see 9 voltage batteries, negative voltage connected with breadboard. So I'm back. As I said and as I showed you before, I do the circuits in off record, and let's let me show my goal in this project. So you can see the circuit. This is the same circuit that I showed you, but some cables location is changed. Some circuits, basic components, sorry, not circuits, basic components location is changed. So the but the main idea is always same. The main work property is same, work procedure is same. If I give the voltage this circuit, it will turns on, and if I do this, you can see the buzzer's voice is reduced, buzzer's voice is decreased because of y equals I times r, the classical equation, the classic equation. Y voltage equals to ampere times I don't really i's in English term, so I say I, ampere or I. If I remember what's its real name, I said it. But in this video, I'm talking with ampere for I. Whatever. Voltage equals ampere times resistance, and if I do this, if I get nearly to the light, the LDR's resistance is increasing and the voltage is the same, so ampere must be decreased, and if ampere decreases, the buzzer's buzzing sound is decreasing at the same time. So what's my main idea, what's my main goal in this project? If I do with this, and you can see the laser is working, which we do at the last video. Here is the circuit, and if I do this, boom boom, and if I shoot with laser sight LDR, if I shoot LDR with laser sight, you hear, or you can't hear because it's not buzzing right now. Sorry, I'm just making distance. Yes, it's quiet. And if I cut this laser sight with using my hand, it will not quite, it will buzz. So I'm doing, and yeah, you can hear it, it's buzzing. This is the main idea of my project. And wait a second, yeah, this is my main idea of my project. In the next videos, I hope in the next videos, in the next week or in the next days, I can't really say anything about it, I will do cardboard house, and after that I'm going to solve this circuit into this Pertinax. Not exactly this Pertinax, the same Pertinax with this, but free space, no anything, and connect it to LDRs in one Pertinax. Okay, thanks for watching me, thanks for listening me, and this is for today. So goodbye and take care of everyone. I'm bad at finish things. So goodbye. This is the main idea of my project, the core circuit of my project, and goodbye. See you next time.